Okay, here we are with example 5. This actually has two equations. One is r equals 3 sine theta, and the other one is r equals 2 cosine theta. It looks very similar to ones that we have looked at before, but the difference is there's a variable that's in front. So I am actually going to open up a page here. So we're going to do r equals 2 cosine theta, and then the blue one was r equals 3 sine theta. 3 sine theta. Okay, let's go ahead and do we can do either one. Probably the 2 cosine theta would be easier. All right. So the question says, use the techniques from the last section to convert the polar equations to rectangular equations. And these equations are the graph of a what, and then we have to graph it. Okay, so we have two of them here. So on the red one, I see that I have a trig function, so I'm going to automatically default to multiplying both sides by r. So I have r squared equals 2r cosine theta. And when I have this, I see this r cosine theta substitutes for the variable x. So I'm going to rewrite this as r squared equals 2x. Well, I also know that r squared is equal to x squared plus y squared. So since this is equal to 2x and this is equal to x squared plus y squared, then x squared plus y squared is equal to 2x. So normally, if we just needed an equation that didn't really, specify, we could leave it like that. But if we go ahead and simplify it and complete the square, it gives us information about where the center of the circle is and what the radius of the circle is. So let's go ahead and move this. We're going to subtract 2x from both sides. I'm going to do x squared minus 2x, and I like to keep my x's together, plus y squared is equal to 0. Okay, in order to complete the square, I'm going to do this over here. X squared minus 2x plus something plus y squared is going to equal whatever it is that I put in here. All right, when you complete the square, I don't know if you guys remember this, but b over 2 squared is what you're going to put in for this value. So it's going to be negative 2 over 2 squared, which gives me 1, right? Because it's negative 1 squared gives me 1. So this is also going to be 1. So I can actually um, graph this out as x minus 1 times x minus 1 plus y squared equals 1. And that would be x minus 1 squared plus y squared equals 1. Here's what this tells us, okay? That my radius is going to equal the square root of 1. Well, square root of 1 is still 1, okay? So my radius is 1. Um, on my y-axis, my center is at 0. And the reason why I say that is because it doesn't move. There's no other term within that y squared. On this one, because I have a minus 1, that means that I have plus 1 for my center. So this is where my center is located of the my circle. So 1, 0 is my center, and it has a radius of 1. So let's go ahead and go back to here. So it has a radius of 1, and 1, 0 is my center. And then if it's a radius of 1, it's going to be a circle that incorporates, let's see if I can get it decent. That's about it. It's a little bit off. But this would be how we would graph that. Okay, So it's a circle, it has a center of 1, 0, and it has a radius of 1. So you'll notice that my diameter from here to here is a value of 2. So there's that one. That's not too bad. All right, let's go to this other one and go ahead and solve this one. Again, I'm showing absolutely every step, so it's not really this complicated. Again, I see a trig function, so I'm going to multiply both sides by r. So 3r sine theta, I see r sine theta, that's going to be y. So I have r squared equals 3y, and then r squared is also equal to x squared plus y squared. So x squared plus y squared is equal to 3y. And again, we have x squared plus y squared minus 3y is equal to 0. And we're going to complete the square on that one. So x squared plus y squared minus 3y plus, let's see here, I worked it out already. Well, plus 3 halves squared, I'm just going to leave it that way, is equal to negative 3 halves squared. And that negative essentially goes away, right? The reason why I'm going to leave it that way is because, um, so this is going to give me a positive number. And so my r is going to be equal to the square root of 3 over 2 squared. So my radius is really, I don't know, you could say plus or minus, but radius isn't a vector, it's a measurement. So it's really, you're really looking at the absolute value of it. Um, so then we get 3 halves, right, is going to be our um, radius. And then we've got to find um, our coordinate. So my center, right, the x value doesn't have anything added to it, so it's going to be a 0. And then this actually equates to y minus 3 halves quantity squared. So 3 halves is going to end up being my, um, where my center is, so 1.5 up on the y-axis. So let's go ahead and graph this. That means my diameter equals 3, because 3 halves is 1.5. All right, let's graph this. So 0, 3.2, 0, so 1.5 is right there. And then my circle has a 1.5 radius, so it's going to go kind of like this. Close enough. It should be, right at 3 on this one. Okay, so those are, the equations are graph of a circle. Let me just graph that. Okay, let's look at symmetry. There's a couple rules here, and we're going to give you guys some additional practice, but I wanted to get these rules here for you. When we're talking about symmetry with respect to the polar axis, that's this one right here. The polar axis is right here. So if that's your mirror, imagine that these two things look the same on both sides. So in a polar equation, replace theta by negative theta, right? So if I go up pi over 4, then if I go negative pi over 4, I should get the same um, the same equivalent, but flipped over the x-axis. Symmetry with respect to the line of pi over 2, that's the fancy way of saying symmetry with respect to your y-axis. So if whatever I have going away from it on that side, I also have going away from it on that side. So here we're going to replace theta by pi minus theta. Okay, so we're going to replace theta by pi minus theta. And really what that's doing is it's saying Let me get rid of these little things here. It's saying that if I have theta here and I have pi here, then minus theta is going to give me that same equivalent on that side. And then the last type of symmetry is symmetry with respect to the pole or the origin. That is the center line, right? So anything that goes out radially from the center is going to be symmetrical to that pole. In a polar equation, we're going to replace r by negative r, right? Remember, we had a positive r up here, and then if it was a negative number, then we would go ahead and move it back to the other side. Or what you could do is you could replace theta by theta plus pi. So we added um, pi to our angle, and that was the equivalent of having a negative r. So you can do either one of those, and that will give you symmetry with respect to the pole, which we know that pole is right here at the origin.